If your breaker keeps tripping, there are exactly 5 reasons why. 3 of them you can manage. 2 of them mean you call someone today. We're going to cover all 5, and we're going to talk about why commercial properties are a completely different animal.
Turn in eco energy. Let's go, go. Plug in eco energy. Go that eco energy. You know.
The breaker tripping is not the problem. The breaker tripping is the warning. The problem is whatever caused it, and that's what nobody explains. A circuit breaker has one job: interrupt the flow of electricity when something goes wrong. It's the last line of defense between a problem in your wiring and a fire in your wall.
When the breaker trips, it's working correctly. It's telling you something that many people don't listen to, but we're going to teach you why you should listen to it. The dangerous situation doesn't come from a breaker that trips.
Right.
It comes from a breaker that doesn't trip.
100%.
Just like we talked about last week.
Our last week's
with
episode.
the Zinsco, Stablock Federal Pacific,
Yes.
and some of those older panels that
Yeah.
were known for these problems.
So are we talking about a lot of fires or just a few fires here?
There are quite a bit of fires. The U.S. electrical fires cause approximately 51,000 house fires per year.
Yeah, the interesting thing to note about that is while it's not the highest ranking cause of fires, cooking is actually.
Yeah.
The results from electrical damages are significantly higher damage.
Yeah.
And they're also one of the leading loss of life in fires.
Right. There are nearly 500 deaths and
Yeah.
and $1.3 billion in property damage every
Right.
single year.
Yeah.
And the thing about it is a cooking fire, right? You're likely in the kitchen. You likely put a little too much oil in the pan and it happened.
Grease fire.
It's happened to me in the past. But
Really?
Yeah, actually. I was cooking eggs one morning and
Oh, no.
used too much butter.
Oh,
Yeah.
wow.
But anyway, you're in the kitchen, right? You're right next to your pan or whatever you're cooking in, and you're aware of it. So
Yeah.
if it gets out of hand,
Right.
start screaming to
That's
everybody to
the
get out
issue
of
with the
house.
electrical is you're not normally aware. So before we get into the causes, give us the data. How common is this? How many people are actually dealing with tripping breakers?
Yeah, so this is one of the top 5 Googled electrical questions in the U.S.
So we're
And
answering the right questions here.
A little bit of personal here. We are in a house of electricians, and we have one breaker that trips on occasion. When you plug in,
No.
we've got an electric kettle, and we have
Okay.
a microwave that
Oh.
are on the same circuit. And I happen to know that you can't run both the kettle and the microwave.
You
on
know
the
what
same
else you can't
circuit.
run at the same time?
Our Christmas tree and our vacuum.
Nope, that problem's fixed.
Okay.
The space heater and a hairdryer.
All right. So it's fairly common.
It's
if
very
we have
common.
it as well.
It happens a lot, especially in the Bianchi household. So, yeah, let's get into the causes, right?
Yeah.
So, first cause. Yes, I'm jumping all over you. Go ahead. Help me out with the first cause.
There are 5 causes,
Okay.
right? The first one is an overloaded circuit,
Right.
which is the types of problems that we were just talking about there.
Yes.
And it happens most commonly when you just plug too many things in, right? Like when our kitchen was built, there was no electric kettle to heat up water. It was
No, they've been around for a long time.
well, we didn't have
we
one.
didn't have one, I
Right,
see, yeah.
exactly. So
Yeah.
it wasn't spec'd out originally.
Right.
It was just the microwave and an appliance outlet for whatever
Uh-huh.
we happened to need. And it wasn't a problem. And
Right.
then at some point, we got the electric kettle and we overload that circuit
Right.
when we run the microwave and that at the same time.
Yep.
And that's what usually happens. You know, you hit the amp limit on the circuit. And it
Kitchen
trips.
circuits are number one offender.
Yeah. Kitchen circuits are big. Garages are also pretty
yeah.
big because
Right.
the same thing happens. When you built the garage, it was a row of lights. Now you've got all sorts of power tools. I mean, there are electric power tools out there even. Lawnmowers, weed whackers, chainsaws are
Yeah.
even sometimes electric.
Yeah.
You're powering much more, and that circuit may not have been designed to handle it from the
I'd like to
beginning.
see a graph from like when the house was built and
Yeah.
the average household energy consumption, and I'm sure it's going to be like a pretty steady uphill climb to today,
Right.
and where we're at with our electrical use, and I'm sure it's either. Probably. See, our house was built in the late 90s, so maybe 2x, 2.5x, I'd imagine. But
Oh, every bit. And I'll bet you there's a pretty big spike when we got that EV charger
yeah,
as well.
as far as usage, yeah.
Yeah.
So kitchen's number one cause. Garage is also a high contender. And in our house, this is a funny story. We actually have a breaker in our panel labeled Christmas tree.
Yes.
The whole reason behind that was we have a 12-foot tree that I like to put a lot of lights on. And I believe there are 18 strands of 150 lights. You can do some math and realize that we're 1.5 watts per light times the number. And then every time my wife would try and vacuum, when the Christmas tree was on, the breaker would trip.
Yep.
And so we ran a separate circuit just for our Christmas tree so that somebody can vacuum when the Christmas tree lights on.
Now, here's an interesting thing about that, because this was years ago that we did it, and I just picked up little things here and there.
Yeah.
Is if we would turn the Christmas tree off,
Okay.
right, and then start the vacuum, and
Yeah.
then turn the Christmas tree back on, everything would be fine.
Oh, that's interesting because of the
Right?
inrush. Yeah.
Exactly.
Yeah.
When a vacuum, right,
Uh-huh.
is an electric motor.
Yeah.
Electric motors have a higher inrush current, meaning when you're first starting it, it's drawing many more amps than
We're
it
going to get
normally
into this
does.
on the commercial end because
That's
it's a
true.
lot more appropriate on the commercial side
Yeah.
of things. So let's keep with residential. What's our number 2 cause?
A worn or aging breaker, right? Breakers are mechanical devices,
Yes.
just like most other things, and they wear out. A breaker that
They do.
trips at loads it used to handle fine or trips randomly
Yes.
with no clear cause could be a sign of a worn or aging breaker.
So if you've got the same amount of appliances plugged in, you're doing the same thing all the time,
Yeah.
but the breaker on occasion trips,
Yep.
that might be a leading indicator that it's actually just a faulty breaker.
Yeah. And one thing to watch out for here is you might think it's a faulty breaker because it doesn't happen every time, but it is still important to check around. And
Right.
we'll get into a little more of what you should check for, but don't just assume that when it's tripping, it's because of a faulty breaker.
The faulty breaker is probably less likely than too much demand.
Yep.
So if you unplug everything on your breaker and then turn it back on, and then you plug one thing in that takes a smaller load,
Yeah.
and it still trips, that's probably a faulty breaker.
Yeah.
Yeah. And that faulty breakers, a breaker replacement is a fairly inexpensive job. And that can be handled by an electrician. In fact, it needs to be handled by an electrician because you have to open the panel.
Yeah.
Anytime you open the panel, you want to get a professional involved.
What's that going to cost me?
So, not much, couple $100, I would think tops.
Yeah.
It's not a real big problem.
Yeah.
It's not nothing, but it's just a small issue.
Okay.
And then, all right, number 3 cause.
Yeah.
Hang on. We started off with cause number 1, which is overloaded circuit.
Yep.
You don't need an electrician to figure that out.
No.
You just start unplugging things.
Yep.
Especially if you have high amperage draw appliances, unplug them, switch them to a different room. Maybe run them in plug it into a different place. That'll help manage that.
The only reason you really would need an electrician is if you're like, no, I want to run that thing right there, and we got to figure that out. Then
Correct.
we can run a new circuit, likely through existing pipe.
Add a new circuit. Yeah. And
Exactly.
because we're in the Chicago market, we can pull
Yep.
it through a pipe.
Yep.
Yeah, that makes it a lot easier. All right. So, and then number 2 we talked about. So is that a manage it or is that a call an electrician part?
Yeah, so the Warner aging breaker,
Yeah.
you're likely going to have to call an electrician.
Not
because-
immediate.
Right. Yeah.
It's not a fire hazard per
Right.
se.
The fire hazard comes with it not tripping.
Cause
at all.
3.
Exactly.
Let's look at cause 3. What do we got?
We've got a short circuit.
Ooh.
That's the dead ringer. It will trip
Yeah.
every time. So what a short circuit is when a hot wire touches a neutral wire somewhere in the circuit.
Right.
Right. So it could be in an outlet, in a switch, an appliance, the wiring itself inside of the pipe. You'll see it on very, very rare occasions where it happens inside of the pipe. But essentially what's happening is the current is taking a shortcut through the neutral to go right back to the panel. Causes a massive amp spike, and it will immediately trip that breaker. How does somebody know if they have a short circuit?
If you flip the breaker back on and it immediately trips,
Yeah.
like boom, if you can hear a pop, if you can hear a bang, if you can hear that, that's typically going to be a leading indicator of we call it a dead short,
Yeah.
which means you've got a hot neutral mix. And that happens actually more frequently than you'd think.
Yeah.
In fact, I got called out. It was an emergency call, and it was last year. And in the evening time, somebody had a dead short in their panel. Called us out there to take a look at it, and the guy was like showing me what would happen when the breaker. When he tried to flip the breaker on, he'd flip it and I go pop, and it was in a darker closet, and I really didn't see, him very well, but I could easily see like sparks
Yeah.
behind the panel every time he flipped that breaker. It's like molten steel falling.
That's exactly what it is. Molten steel or copper.
And I'm like, hey, I don't think you want to keep doing that, because he kept flipping it back on. See, it just won't stay. Click, boom, click, boom. Dude, you got to stop. You're going to burn your house down. And sure enough, we found the dead short. We corrected it, and we put in a new breaker. Because once you have that dead short experience, especially when you've got somebody flipping it back and forth, back and forth, back and forth, that breaker has taken a lot of abuse right there, and it's not going to trip properly moving forward. That's where you're going to have a weak and worn out breaker situation going on, where it's not going to be able to work. And you know what the interesting part is? He had an electrician out there 2 days prior who just decided that he was going to swap the main breaker with a used breaker that he had.
Wow.
And who knows what happened, but definitely check credentials on these guys, man. There's just some people out there. So an actual fault, a short circuit, absolutely, that is not a manage it. That is a call now. Call now, get an electrician in there. That is a high likelihood of fire risk.
Yep.
Is when you have a dead short.
And the other thing is, an electrician is going to know to look for some things that you as a homeowner might not. Look for damaged wiring, because a dead short can damage wiring, not necessarily just at the point,
So
right?
that is actually the number one cause of house fires is old worn out insulation on the wiring, which causes a direct short.
Yeah.
And we have, as an electrician, you have a meter, and you would be able to test for a direct short. Right at the panel, you can tell. You don't have to flip the breaker back and forth to see the direct short. You can actually use your meter, determine that there's a direct short, and then make the correction necessary.
Yeah.
And that involves a little bit of time to figure out where the problem is.
Yeah.
It's not often that the direct short is in the pipe somewhere. It's typically at the outlet. However, we were talking to somebody who's out of state recently, who had a dead short in his circuitry, if you remember that. Kept tripping the breaker. Yeah.
I don't.
So if you have a dead short, definitely that is not something you want to deal with yourself. That is house fire stuff. You want to get that handled by an electrician right away.
Yeah.
All right. Are we on cause 4?
We are.
All right.
Cause 4 is a ground fault, right? So explain to me, what is a ground fault receptacle breaker? What is that?
So I think what we're talking about is why a breaker trips because of a ground fault, and that is a direct connection with the hot wire, the L1 or L2 in your panel contacts a grounded part of your system. Yeah. And that is like if you have conduit, it's if that hot wire is in contact with the conduit. If you are in a Romex area, that would be if that hot wire is in contact with your grounding wire or a steel box or anything that would be that would lead the leg or the feeding cable to the ground, which is another indication. That's a ground fault, and that is a also will immediately trip the breaker if you have good grounding.
Right.
And I'm gonna talk about this because I've seen it multiple times where an ungrounded system causes the pipes to be energized. and I'm going to give you two examples. One is a residential scenario and one is a commercial scenario. As part of a program, we were removing knob and tube wiring in houses, and I believe this one was in Joliet. And at some point in time, they had used wire mold, which is like basically a steel channel that runs along the outside of the drywall.
Yeah.
And they somehow had damaged the hot wire when they were pulling it through the wire mold, and it had a direct contact with the metal that the wire mold was made of.
Yeah.
So it energized all of the metal channel that was running along the wall. So at any point in time when you touch it, you were at risk of electrocution. You'd definitely be shocked. And I took my non-contact voltage meter and held it right up to the channel, and it lit up. So that's a ground fault. However, it did not trip the breaker. Those are the most dangerous situations. The second one, we were called out to a grocery store, and it was a self-checkout unit that the cashier said, yeah, every time I come over here to check the machine, I get shocked. And I took my non-contact voltage meter out again and held it right up. The entire self-checkout was electrified. So somebody missed connecting the ground wire on that because it should have tripped the breaker. The normal reaction is the breaker trips because of a ground fault. When the ground is not properly connected, though, it will not cause a fault. What it will cause is everything that's metal to be electrified, and therefore every time you touch it, you're going to get a shock. And that's a dangerous situation. So ground fault is absolutely call an electrician because you have immediate danger. That's 100%.
I saw one in a garage in Lansing with all exposed pipe, and same thing. You would put your non-contact voltage meter right up to the pipe, and it would show that it was electrified because there was no good ground connection from the garage back to the panel.
Right. And if you want to check your ground connection, you want to verify that you have a good ground, go ahead and you can buy them at Home Depot or Menards or whatever, Lowe's, for probably $20. And it's a little thing you plug into your outlet, and it'll show you if you have a proper ground. And it's a super cheap thing that you can do yourself. Check and make sure that you have a proper ground there. There's a series of lights there. They typically have 3 lights. And 2 of them will light up, or 1 green light, or however.
And there's the code on
there.
There's a code
on
there.
You can read it.
What it is going on. But ground fault, very dangerous.
And for a homeowner, you can check your stuff. Just go get one of those little testers for $20 and plug it in and make sure that you have a proper grounding. And that, like I said, is one of the leading issues to electrocution or electrical shock. Electrical shock more often. Electrocution rarely happens, but it could. It could. All right. Call 5. The electrician for number 4. Number 5. What do we got?
We've got an undersized circuit for the load.
Okay.
Right. So this is one where the circuit was never designed for what's on it, and we kind of touched on this a little bit. But it's a classic example where, a 15 amp circuit was feeding, let's say, a home office in this scenario. It now runs a workstation, monitors.
Got your 50-inch monitor, drawing 300 watts. You've got a little space heater under the desk.
You've got a printer. You got everything, man. You've got a great setup.
Got a laser printer, which draws a lot more electricity than an inkjet.
Yeah, exactly. And, it can happen in home offices, garages, kitchens are also a big one. But
can't we just put a bigger breaker in?
I have been asked that so many times that it's not even funny anymore.
Just put a bigger breaker in.
And I've actually seen a scenario of that where I went to a homeowner's house who was having issues with the tripping because he had expanded. And it was a 15 amp breaker originally. And he had taken some initiative and put a 20 amp breaker right in there. And then he, the 20 amp breaker wasn't cutting it either. So he put a 30 amp amp breaker
Yeah,
in there.
30 is the next logical option.
And that's where the problems really started. So we had burnt up wiring all through that pipe, and
Yeah.
it was, the breaker had done its job, right? By the
did.
time that it got that bad, the
Yep.
breaker was tripping, and
Yep.
it was a much larger job than it needed to be.
I think you said it in one of our first slides that we had here was the breaker is doing its job by tripping.
Yep.
You don't. The answer is not a bigger breaker. So dive into that a little bit. Why can't I just put a bigger breaker in?
Yeah, so your wiring, right, is what is feeding electricity from the panel to your load, whatever you have plugged in or
Yeah.
running, whatever. Your breaker is sized to protect that wiring so that under a full load scenario, that wire will not burn up before the breaker trips. Now, different wires can handle different amount of electricity or
Right.
different amps going through them.
Okay.
So a 15 amp breaker you can run with number 14 wire, right?
Right.
We all know that as electricians.
100%.
A 30 amp breaker, you need to upsize that wire all the way to number 10 or even bigger in some cases. And what happens is the number 14 wire that's plugged into that 30 amp breaker isn't rated to carry that current, and it will literally melt the insulation, and if very rarely, but it could start to melt that copper as well in there.
Yeah, I've not seen it melt the copper, but I've sure seen burned insulation.
Oh yeah.
Yeah, in that scenario.
Yeah.
So how about the undersized circuit for the load? Is that a manage it problem, or is that an electrician column?
You know, it could go a little bit of either way.
Yeah.
If you're looking at it and you're like, well, you know, I've got my fridge plugged into this outlet
Yeah.
that's on the same circuit as all my other stuff,
Mm-hmm.
but I could move that right over there. That's not a problem. Then that could be a manage it.
I think it's more of a manage it problem.
Yeah.
Definitely don't upsize your breaker.
Yeah.
Unless you have a qualified electrician, take a look at that wire. And a lot of times there are 15 amp breakers on number 12 wire.
Yeah.
And you can upsize it to a 20 amp.
Yeah.
But you need to check and make sure that everything downstream of that breaker is number 12 wire, because
Right.
if you've got number 14 wire and you upsize it to a 20 amp breaker,
Yeah.
you're going to have an issue.
Yeah, exactly.
Yeah.
And that's one of the biggest things is every once in a while you'll open a panel and there's a number 12 running into a 15 amp breaker and you're
Yeah.
like, oh, awesome. I can put a 20
got
amp breaker
headroom.
in there. Right. But then you look a little downstream and
Yeah.
at the first outlet it switches to 14 gauge and then continues all the way 14 gauge.
Yeah.
You got to stick with a 15 amp breaker.
Yep. Safety first.
Yeah.
All right. So here we are talking
Commercial,
about
right?
Yeah, should we jump to commercial? I think we've done enough residential
I think
stories.
so.
Yeah.
I think that covers all of it.
Let's jump over to commercial. So commercial properties operate at a completely different scale.
Yeah.
Higher voltages, three-phase power, large breakers, more complex loads, and the tripping reasons differ significantly from the residential reasons.
Yeah.
There is some overlap. You still got your ground fault, you still got your short circuit, you still
Yep.
got overloads on
Everything that we said still applies.
Yeah.
There's just a little bit more to the
a
equation.
little
I
more
think.
complex because of
Yeah.
I think probably because of the equipment, and then the diagnostic process is different.
Right. Yeah.
Okay, so really, there's probably, let's talk about 5 causes. Huh?
Yeah.
Maybe keep it with the residential. Let's give me a cause that what would cause a commercial breaker to trip.
So here's one that we actually mentioned a little bit on the residential side, but a motor starting current and rush.
Absolutely.
Yeah.
Yeah.
So like we talked about with the vacuum, which is a much smaller case on the residential side, when you're starting that electric motor, there's an inrush of current where it takes a little bit more electricity.
Like 6 to 10 times more electricity.
Quite
Yeah.
a bit, yeah. To start up that motor than
Yeah.
it does to just continuously run it.
Yeah.
And so electric motors, HVAC compressors are a really big one that we see this on.
Heavy loads.
Yep. Refrigeration units, elevators, pumps, air compressors, all of those draw 6 to 10 times their running current for a fraction of a second when they start.
Yeah.
No.
And it might be more than a fraction of a second if it's a hard start.
Right. Yeah.
I've seen them hum for a few seconds
Yeah.
before they take off.
Especially as they're getting a little older, aren't greased regularly.
Yeah, they're not exactly up to moving around
Yep.
all that much anymore, And the older the equipment, the windings get weak on the motors,
Yep.
and you get much higher inrush. I've seen a 30 amp motor draw over 200 amps on an inrush.
Yeah.
And the breaker doesn't trip. The breaker's
Right.
just fine. It just sits there. Breakers are designed for allowing for inrush current, especially motor rated breakers, which if you're heavy horsepower, you need to make sure that you have those motor rated breakers for those, because it will handle the inrush and it won't
Right.
trip. It won't nuisance trip, basically. It'll only trip when there's an actual problem.
Yeah. Which is a little bit of an interesting thing, right? Because you'd think 30 amps on a breaker,
Yeah.
as soon as you go over that 30 amps, it would trip.
Correct. It doesn't
Why-
happen that way.
Why doesn't that happen? How do breakers trip?
Breakers are it's a curve, a time amperage curve, basically.
Well, it's heat, really, right?
No, not under that circumstance. A direct short would be actually no, that one would be the heat trip. I'm thinking of short circuit. The
Oh,
short circuit
okay.
trip is an immediate.
Yeah.
So there's a heat disk inside of the breaker, and that's basically what causes it to trip. Is the thermal of the breaker tripping
Yeah.
at a certain amperage for a certain amount of time. So you might be able to draw 30 amps on a 30 amp breaker. You could probably draw 30 amps pretty continuously without a trip.
Yeah.
If you draw 35 amps, you could probably draw 35 amps, and I'd really have to look at a graph to tell you exactly.
Yeah.
But probably 5, 10, 15 minutes, you can draw 35 amps, and that breaker won't trip.
Well, we see that a lot with the EV chargers,
Okay,
right?
yeah.
A 48 amp EV charger needs a 60 amp breaker,
Right.
Because we have to upsize the breaker because of that thermal limit, and the same carries over for anything.
Yeah.
But breakers trip in two instances. One of which is by the thermomagnetic strip bending as it heats up,
Okay.
and that causing the breaker to trip.
Yeah.
The other one is a short
The
circuit
instantaneous
trip.
trip.
Instantaneous. Yep. Completely different things. But most of the time, breakers are tripping due to the thermal. Would you agree?
Oh, 100%. Yeah. Yeah. It's not common to see a short circuit.
Yep.
Or not as common to have
Right.
a short circuit issue. Yeah.
Yeah.
So, all right, there's our number one cause probably for that.
Now, would you say that's a manage it, or do we need to call an electrician for that?
So I would, if it happens once,
Yeah.
not a big deal. If
Yeah.
it's happening regularly, yeah, it's a big deal. If it's happening once a day, if it's happening once every other day or something like that,
Yeah.
absolutely, you need to get an electrician involved to see exactly why it's drawing the excess amps.
Especially when it's been in place for a little bit, right? It didn't used to do this. It's
Right.
all of a sudden doing this. It points to something being
Something
wrong.
changed with the equipment and
Yeah.
needs to be looked at 100%.
Yeah.
So, the restaurants are probably one of the higher, because their equipment, and I would say probably manufacturing as well, we probably see the same thing.
Yeah.
But like I've seen a lot of crazy stuff more in restaurants than anywhere else, but I never cease to be amazed at what I see going on out there.
Right.
I was on the phone with one of our techs today. They've got a 480 volt circuit.
Yeah. 3-phase.
It's 3-phase, 100 amp overcurrent protection on number 4 wire, running 150 feet. So your voltage drop is significant, and then on top of that, you're with 103 FLA. So yeah, it's that wire's rated for 85 amps. It's actually drawing 103 amps regularly.
Yeah.
And the customer wants to add another machine that draws another 47, I think it was 47 amps onto that.
Yeah.
And said, can't we just upsize the breaker and splice into the wire? I mean, you can do whatever you want to try and do, but when it burns down, please, I was never here.
Yep.
Yeah. It's one of those things where, it's been working for years in that scenario. But what happens is, because of the voltage drop over that long run, you're prematurely wearing out your equipment.
Yeah.
because it can't get the voltage it needs, and then it ends up overheating the wires, overheating the connections, and they probably have higher maintenance costs in that unit because it's not properly sized.
Oh, absolutely.
So we try and look at all that stuff when we're evaluating it. Just make sure that, hey, you've got a healthy situation here, and you should be good.
Yeah.
And I mean that's worth having somebody take a peek at. And
Oh, absolutely.
you know, most of your electricians really do know what they're talking about, and they can use an ampacity chart and tell you, okay, your wire's undersized or over, you know, you're okay. There's no real such thing as oversized. You can't necessarily use a wire that's too big unless it
Right.
just won't fit on a connector. You know?
Right,
That's,
yeah.
That's about the only reason why. But yeah, that definitely, we see that a lot in commercial, industrial. Restaurants are notorious offenders of these things. And we had one restaurant where the breaker literally melted the panel because of an improper install. They had a non electrician installing a 3-phase booster heater for a dishwasher, and it kept tripping the breaker, so they kept resetting it. Breaker trips, reset, breaker trips, reset, breaker trips, reset. Well, you can only do that so many times before the actual breaker will get so hot that it will melt the actual panel, and it melted the actual panel, resulting in a $7,000 repair instead of $100, $150 call out to tighten up the lugs on the breaker,
Yeah.
because that's all it would have taken.
Yeah.
Was a competent person to look at it, tighten up the lugs on the breaker, because that was what the problem was. The breaker was loose. It was installed improperly. Wasn't torqued right.
I had a very similar thing about 6 months ago. Same thing, restaurant. It was an HVAC unit on the roof.
Yeah.
Likely the breaker was installed by the HVAC tech.
Yep.
And the wires had, because of those loose connections, just like yours, they had melted the lugs
Yeah.
on the breaker. So you couldn't even turn that screw anymore.
Yeah.
And if they had called us after the first time or the second time that it tripped, we could have just tightened
Yeah,
it
we
right
could have
up.
tightened it. Yeah.
That breaker cost almost $400.
Yeah. Yeah.
And-
Just little mistakes. And
Right.
then plus the inconvenience of being down. I mean,
Yeah.
that's one thing we really didn't even address is
Right.
downtime. You know, without having that dishwasher, that restaurant technically needed to be closed. The health
Yeah.
department would have shut them down in a minute if they would have gone out there and found it, you know?
Yeah.
So anyway, that's that. Let's get on to the next cause.
Harmonic distortion
Yeah.
from electronic loads. This is an interesting one. You see this in like office spaces a decent bit, I would say,
Yes.
is the biggest offender.
Data centers is
Oh,
actually
yep.
the biggest offender.
Data
Yeah.
centers.
Yeah.
Newer, so I don't think of them as much, but
Right.
you have a larger number of computers, LED drivers, VFDs, which are variable frequency drivers,
Right.
and other electronics that generate harmonic loads that can cause neutral conductors and breakers to overheat, even when individual loads seem within spec.
This is something that probably 90% of you will not have to deal with.
Yeah.
But honestly, everything might look good on paper. Hey, the wire was configured properly. The breaker sizes are configured properly. But we have this one random breaker that trips, and we can't figure out why. And oftentimes it's due to harmonics, and that needs an electrician to figure out.
Yeah.
Yeah.
And this happened a lot back in the early 2000s
Yeah.
when computers
First
first
came out.
become like
Yep.
popularized.
When everybody's got one at their desk now. Yeah, it was a mystery for electricians for a while.
Yeah.
On why these random trips were occurring, and then we figured out the harmonics. Now, the newer equipment does have
Harmonic dampeners.
yeah,
what they're
on
called.
on the wires themselves, typically inside the unit, harmonic dampeners, so that there's less on the system.
Yeah.
And it's probably not a real common cause, I would say.
No.
Yeah. All right.
It's rare.
Let's get on to the next one.
All right, unbalanced three-phase loads. Your house is a single-phase service, and your business is likely a three-phase service. So commercial properties with three-phase service can develop load imbalances,
Right.
right? And a lot of times it happens when one phase carries significantly more current than the others. It causes those wires to overheat and
Yeah.
the tripping of the overloaded phase, and typically it's all three that trip.
So You're pretty familiar with the load calculations you do
Oh
for
yeah,
residential.
very.
So for load calculations for commercial, which I don't, maybe you've done some of.
I've done some.
Okay, so have you done like phase balancing with that?
So
Well, your stuff is all three phase though.
all of my commercial stuff has been three phase.
So when you're dealing with three phase, it's a dead issue.
Yeah.
When you're dealing with single phase loads on a three phase panel, so restaurants, even offices, when you have say one leg that's carrying all of your lighting, one leg that's carrying all of your outlets, one leg, so because it's not balanced, you create heat on the unbalanced leg.
Yeah.
And to get into explanation on how electricity works, I'd need about 8 hours of your time and then another 100 hours of your time to kind of explain how that works. But to say, that an unbalanced load does cause additional heat on the leg that's unbalanced.
Yep. And while I may not have done a ton of three-phase load balancing work, I've done service work on these things, and I know what it looks like, right?
Yeah.
So, when you have a main breaker that's tripping, one of the first things I do is I'll put my meter on each of those phases, and you will likely be able to tell pretty quick which one is way higher than the other. You might have a 100-amp panel, and phase A is drawing 20 amps, phase B is drawing 89 amps, and phase C is drawing 6 amps. Okay, phase B is obviously the problem.
Big imbalance.
Yep.
You need to just relocate the breaker positions in the panel.
Yep.
And oftentimes that'll cure it.
Yeah.
Yeah.
That's been my experience with it, at least.
Yeah, because one leg out of balance will trip your main.
Yep.
And then you've got an issue.
Yeah.
But yeah, an electrician should be able to. Any electrician that you call out there should be able to use a clamp meter and check L1, L2, and L3 and make sure that you've got a fairly balanced load.
Yeah.
It helps the grid. It helps everything to have a balanced load.
Yeah.
We're required to have a balanced load whenever we do a new construction building.
Yeah.
The engineering drawings have to show that it's a balanced load. And then our breakers have to go in exactly where we say they're going to go.
Yeah.
Because when we unbalance it, we're going to cause grid issues. We're going to have other problems.
Yeah.
The load on the transformer is significant.
And that's the other thing. This typically doesn't happen on new builds. It
Right.
typically happens 10, 20, 30 years
It's
down.
after they've switched stuff
Right.
out and added this and added that,
Yeah.
and that's on to our next topic.
Exactly.
Yeah, go ahead.
So it's demand spikes and simultaneous load switching. So in a commercial setting, multiple high draw loads switching on simultaneously can spike demand beyond what the panel was designed for. Opening time, when you're turning on your HVAC compressors, all of your lighting in the entire building, it's all starting together in the morning, and that's when your startup amperage is higher.
So we have this exact problem on a manufacturer who's next door to a grocery store, on a very old grid. The power there is not very clean, and this manufacturer has robots.
Yeah.
Robots, if you don't know, are very, very sensitive to electrical spikes and drops. They have had consistent issues with voltage drops and spikes, leading to robots' memories being wiped out. So they can be in the middle of a job and then just stop and then go to resting position and then stop working from there on out. And if you're in a manufacturing environment and you have this happen, your robot keeps losing its memory or it keeps quitting mid-cycle, you likely have issues with your power coming in, incoming power.
Yeah.
And that's a relatively complex problem to solve. That is we need to do a load calculation. We need to figure out how we can either put a power scrubber on there or how we can use a UPS, especially in those. And that's the route we're going with this particular one, because the UPS, I think, is their only is their only route, and that's an uninterruptible power supply. For those who don't know, it's basically a battery that gets power from the grid. It inverts it to the DC voltage, and then it inverts it on the opposite side for 208, 120, 208, three-phase distribution. So it literally transforms the power from your AC coming in to DC, and then from DC back to AC going out. You say, well, that sounds like an efficiency issue. It's really not. They're very efficient.
Yeah.
But the main thing is having a separately derived system, you have super, super clean power. You're going to get 208 volts consistently within 1 percentage point.
Yeah.
It's very, very, very tight tolerances on that. So, that happens more frequently than you'd like to think.
Especially in those manufacturing scenarios where any downtime costs a lot of money.
Yeah.
It can make sense to dive into that.
So their main robot was down for probably 2 weeks at last check.
Wow.
because of this issue. That probably cost them somewhere in the neighborhood of $300,000 to $400,000 in production.
Yeah.
It's very expensive
Yeah.
for businesses to be down. So yeah, we have to look at what's causing the issue first, and if we can pinpoint it to the power coming in, we can do power monitoring, and make sure it's not a utility side issue.
Yeah.
And it might not be a utility side issue. It might be internal to your production,
Right.
which often happens. I mean, they've got ovens there, 50 amp ovens. There's probably 9 of them in there. So when those kick on and kick off, kick on, kick off, kick on, kick off, if 3 of them kick on, that's 150 amps
Yep.
of power, draw on there. It's going to drop your voltage.
Right.
I mean, they've got pretty good amperage coming into the building, but overall demand they're redlining it, to be honest, to be fair.
Yeah.
And so that is really undersized for the business growth. They've grown a lot over there, and they haven't quite brought the power up to their demand needs.
Right. And the undersized business growth is something that is honestly a great problem to have.
Yeah, that means your business is growing, you're manufacturing more, you're doing more, you're pushing more volume, and that's a great problem to have. The problem that nobody ever wants to look at, and it's that's a pretty big power box over there. I think we can get a little more out of her.
Right, exactly.
Meanwhile, I mean, when we go to places where there's 6,000 amp service, and they're drawing 5,000 amps on the regular, and then they want to add in 10 more new lines, and there's just no headroom. There's absolutely no headroom.
Yeah.
And that now we're getting into, okay, now we need to update our switch gear. Now we need a full shutdown from the utility. Need to bring in new lines from the utility. That is a real big pain.
Yeah.
Nobody wants to hear that. But at the end of the day, the more we automate, the more we get into robots doing tasks instead of people doing tasks. You don't have a plug on you, do you? Like I can plug you in and recharge you?
No, I do not.
No. So people don't have plugs, but all these machines do.
Yeah.
All the machines require power, and it's not a small amount of power.
Yeah.
40 amps, two pole, 40 amps. That's for a simple machine.
Electric forklifts.
Yeah. There's a lot. There's a lot to this. All right, let's keep
everywhere.
rolling around. Biggest mistake commercial property owners make that residential people don't.
I would say treating these problems as a maintenance problem instead of an electrical problem.
Right.
Like, oh yeah, breaker flipped again, just go flip it back.
A lot of times they just leave it off.
Yeah.
That's what I've seen. Or I had an owner one time who called and said, "Hey, the breaker keeps tripping, and I'm not quite sure why, but can you come and check it out?" "Yeah, sure, we'll go and check it out." Well, your steam table has a bare wire that's rubbing up against the metal in there, and that's why it's tripping the breaker. "Oh, well, we'll just keep resetting it." Okay.
Yeah.
Meanwhile, the chef is going to get electrocuted,
Yeah. What would you say the biggest mistake commercial property owners make that residential people don't?
probably not addressing issues in the right manner. They a lot of times the guy making the decision on the maintenance is more concerned about his maintenance budget than he is about shutting down a line.
Yeah.
You know, and we trust me, we have to live within budgets as well. And I can tell you for sure that maintaining something ahead of time rather than shutting down a line is a whole lot cheaper.
Yeah.
Every single time. When we go in, it always happens. We've got one food production guy who just every time something breaks, it's on a Saturday,
Yep.
and it's, you know, the thing's been broken for 3 days and he just never called you, but now it's an emergency on a Saturday because now he can't run. And
Yeah.
anyway, the people, you know, $150 to $500 service call will save you $10,000 in a line being down.
You know, it's interesting. According to the Department of Energy, power interruptions and power quality issues cost U.S. businesses an estimated $150 billion every single year.
Yeah.
Billion with a B. That's crazy.
It's not really surprising, to be
Right.
honest, after having seen lack of maintenance, and nobody wants to put money in the electrical system because you don't see it. It's
Yeah.
not something that brings new customers in the door. you know?
Right. Yeah. It just costs you when it's out.
Absolutely. Yeah. All right. So let's talk about the danger zone.
Yeah,
When
so
tripping breakers become an emergency.
yeah, and we've talked about some of these things you can fix yourself,
Yeah.
and you don't necessarily need to call an electrician for.
Yep.
But these are some of the things that should be giant red flags that you need to call an electrician
Danger
for.
zone.
Yep.
All right.
So if you've got a burning smell from the panel,
Uh-huh.
or an outlet or a switch or anything that has electrical inside
Yeah.
of it, a burning smell, call an electrician because something is burning.
Absolutely. Yeah.
What else?
Get on it right away. Much along that line, you can see burn marks, scorch marks on outlets or switch plate covers. You'll see that stuff, and
Yeah.
I routinely see it in like walkthrough inspections that we do,
Yeah.
where that outlet melted, so we just don't use that one anymore.
Right.
Breaker trips immediately every time you try and reset it, like the guy at the house. Just keep clicking that thing on, boom, 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 boom.
Short circuit.
Man, stop! You're making the problem worse, not better.
Yep.
You're not fixing it. And at some point in time, the booming is going to stop and the breaker will reset, but the wire completely melted in the wall.
Yep.
And then you've got a much bigger problem.
Yep. If the breaker trips immediately, or a loud pop or crack,
Yeah.
right?
Yeah.
Both of those things, dead ringers of a short circuit
yep,
somewhere.
Short circuit or
call an
ground,
electrician.
ground fault. Yep.
Yep. Or even if it feels warm to the touch. I know
Yeah,
that I talked.
warm's probably okay. Hot is not okay.
Yeah.
Yeah.
I talked about it last week where I was feeling breakers and 6 of them were hot, like hot.
Yeah.
And that was a panel bus issue. We had to
Yes.
replace all of those breakers, move them to different spots. But that's dangerous.
Same thing, multiple breakers tripping at the same time.
Yeah.
That's an indicator of a bus bar issue, not a breaker issue,
Yeah,
and that's where you
exactly.
need an electrician in there. So
Yeah.
definitely top things. Homeowner, building manager, don't replace a 15 amp breaker with a 20 amp breaker. For
Yeah.
God's sake, a 30 amp breaker because it keeps tripping. The wire behind, the wire downstream of that was not rated for those breakers. So please don't do that ever.
Yeah. Have you ever arrived at a job where somebody had already done the wrong thing? Bypassed a breaker, upsized it to a 20, 30 amp, and, ignored tripping for too long?
Well, it hasn't
One story.
happened.
One story.
It hasn't happened today, but pretty much every single day of the week,
Yeah.
we get a call. Something like that happens. Yeah, of course. The thing, I think people want to think that the problem's gonna go away.
Yeah.
If I just keep resetting or I keep doing this or I keep doing that, it doesn't.
Right.
Just call somebody out. It's going to be a whole lot cheaper to fix it early on than after you've done all the extra damage to it afterwards.
Yeah. Absolutely.
So back to kind of like the full circle here.
Right.
DIY or call somebody. And
Yeah.
we kind of will high level this real quick. Honest framework. If the breaker tripped after you've plugged in a lot of things onto that breaker, do you need to call me?
No.
No.
No, realistically, just unplug some of that
Unplug a
stuff,
few things.
flip it back on.
What about if the GFCI keeps tripping? Press the button on the outlet itself, not the panel, and it holds and it's done.
If it stays in the reset position, then you're probably fine. Nuisance trips on GFCIs happen.
Yep, absolutely. Lot, actually.
Yeah.
And I mean, it happens in the commercial world as well, where
Oh.
you got a GFCI. Especially, we see it a lot on proofers, coolers,
Okay.
proofers, prep tables, where they have a pan that collects the condensate. Inside that pan is a heating element. That heating element will get a tiny hairline fracture in it, and it causes a ground fault.
Yeah.
Normally, if you switch the breaker from a GFI to a regular breaker, it won't happen. But that's also a ground fault
Yep.
that needs to be addressed, right?
Yep.
And I hear refrigeration guys or heating HVAC guys out there, oh, get that GFCI breaker out of there. Well, I'm sorry to say, but the code says that you have to have it there. So go ahead and fix the equipment the right way.
And people say this all the time about the fire code, that it was written in blood, right?
Yeah.
The electric code is the exact same way.
100%.
It is in there because somebody got seriously injured or,
Yes.
God forbid, died.
They don't put things in the code for just to make your life harder.
Yeah.
Literally, somebody, almost always somebody died,
Yeah.
and that's why a code change.
Right.
And it's oftentimes not just one person, but
Right.
multiple reports of people dying or serious injury
Yeah.
occur, and that's why a code change. That's
Yeah.
why GFI breakers are required in all kitchen areas.
Yeah.
Because the guy mopping the floor is going to come in contact with that cooler that's got a ground fault, and he's going to get electrocuted.
Yeah.
He didn't do anything wrong. He's mopping the floor, doing his job, and that the water from the mop is causing
Current can travel through it.
a path of travel from the cooler through the mop. Guy gets electrocuted. It happens. That's why GFIs are required in every appliance 250 volts or less.
Yep.
So, okay. What do I need to call an electrician for?
All right. And we just covered these, so we'll go through them quickly.
This is a summary.
The breaker trips every time you reset it. Stop resetting it.
Yeah, please, for the love of all things holy.
Any burning smell, any scorch marks,
Yes.
or warmth, like excessive warmth coming from the panel or outlets.
Yes.
If you've redistributed the loads and it still trips,
Right.
the circuit might be undersized. Call an
Correct.
electrician; they can fix it.
Easily fix it
Yep.
without a house fire.
Yep.
Yeah.
Exactly. A brand new appliance, right? Especially like say you had somebody come out install an EV charger and they didn't do a load
Doesn't
calculation.
everybody install those correctly?
I wish. I wish it would make my
How
my
many
fix it.
times do you get a call from somebody who had an EV installed and it was done improperly and now they want you to come out and fix it, and why is it costing me money?
Here's my favorite is when they called us once to give them a quote. We gave them a quote and they said, "Oh man, I'm sorry, that's above my budget."
Yeah.
I get it.
Yeah.
We're not for everybody and this might not work. And
Right.
then they call back 3, 4, 5 months later.
It's usually
"Hey,
about that cadence. Yeah.
this isn't working right. Can you come out and fix it?"
Well, the guy came out and installed it for $600, and now it's not working right.
Right.
Or my vehicle's not charging at the right pace.
I
right?
had that this past week.
Yeah, it's just it
Yeah.
never ends.
And the last guy isn't picking up the phone. I don't want to go off on a tangent here. But any of those things, brand new appliance, tripping breakers, call an
Yes.
electrician. That's not supposed to happen.
Right.
If you're in a commercial building and a breaker trips during normal operating loads,
Yeah.
like you're not doing you didn't have a bunch of stuff plugged into
Right.
that circuit, a
Right.
motor that's run for 10 years just fine is starting to trip breakers, call an electrician. That might be a loose terminal, that might be a bad motor, that might be any litany
Could
of
be something
things.
very easy, and in fact, most cases it is pretty easy.
Yeah.
Unless you've ignored it for a really long time, and then it
Yeah.
becomes a really big deal.
Yeah.
So a diagnostic service call looks like one of our techs going out to the field
Yeah.
with a fully stocked truck of,
Yeah.
of potential problems that could be, and he evaluates the situation, can very I mean, normally the diagnostic is 15, 20 minutes, half
Yeah.
hour tops.
Yeah.
And then they will diagnose what's causing that breaker to trip. They'll find it relatively quickly. They'll be able to diagnose it, recommend a path for repair, and that initial call out is very cheap.
Yeah.
Depending on what's wrong will depend on what the cost will be for repair.
Yeah.
But generally speaking, don't not call an electrician because you think it's really expensive to have them come out. Most electricians come out at a fairly reasonable cost in order to give you a diagnostic.
Yeah.
So it's a very simple phone call and a very simple process that we've taught our people how to diagnose pretty well.
Yeah.
They know it real well.
Yeah.
We actually intentionally stick them on, especially on some of our projects. We'll put a journeyman with a kind of like a fresher
Yeah.
licensed guy, and have them learn from each other.
Yeah.
And the customer never pays the cost for that. We absorb that because we
course.
really want our people to be cross-trained, well-trained.
Yeah.
And it's worth every penny to us to invest in those guys. So it's oftentimes a real simple fix. And, we're going to be honest with you.
Yeah.
Hey, your breaker's tripping because you got your space heater plugged in, you got your curling iron plugged in, and you tried whatever, plugging in another vacuum in that same circuit, and it's
Yep.
just too much for that circuit.
Right.
So,
And then that's where you have an option. Do you want us to pull a whole new circuit to this area so that you can
Yeah.
have this and this outlet on different circuits?
yeah,
Or do you want to just unplug something, move it to a
There you go.
different room?
yeah, pretty simple. 3 things to know, Conrad. Go ahead.
All right. The breaker tripping is not the problem, just like we said in the beginning.
Yeah.
It's the warning. That's the breaker doing its job.
Right.
Figure out why before you reset it again is always a good idea.
Yeah.
Number 2, if you smell burning, burning, see scorch marks, anything that makes you think something is burning,
Yeah.
immediate call an electrician
Yep.
thing, because that is how house fires start, and that is the last thing we want to see.
Yeah.
Stop just resetting it every day when it goes wrong.
How about our commercial guys?
All right. Commercial property owners, a breaker that trips repeatedly is not a maintenance nuisance. It's a business liability.
It's
You've
going to
got
cost
safety
you
stuff.
a lot of money to be down. Fix it before it becomes a big issue.
Yeah.
Yeah, 100%. Well, if you're dealing with a tripping breaker, residential or commercial property, you're not sure whether it's a manage it situation or a call someone today situation, yeah, definitely phone call. We'll give you the heads up. Hey, yes, you need somebody out there, or nope, this is a you manage it type of a thing.
Yep.
What's our phone number?
708-872-8404.
You can find us online too at ecoenergy, the number 1.com. And yeah, it's been fun, guys. Thanks for another great week, and we look forward to seeing you again next week.